Hello, everybody. Welcome back to another session on logic development. In the last session, we have gone ahead discussing some basic aspects about how do you go ahead uh, designing a solution. That is what we had reached a stage where we talked about algorithms. So we identified how an algorithm has to be designed. So the steps that we followed was when we have to solve a problem. The first step was to identify the problem. The second step was to the requirement specification, define the requirement specification. Third step was, what was the third step?
Algorithms.
Algorithms. So we had reached to that particular stage where we talked about designing an algorithm. Now it's time for us to move ahead. Now think about it. You are about to solve a particular problem. I told you yesterday that you have to think like a consultant, and you started with all the right things. You first made an attempt to define the problem. After defining the problem, you understood all the requirements. What is the input? What are the outputs? What are the constraints? Then you have come with an algorithm as well. Now that you have come with, we feel now that since I have come with an algorithm, it is time for me to actually go ahead implementing that algorithm. That is the first thing that comes to our mind. But then you have to be very, very careful over here. Now, why should we be very careful over here? And why we should not be in a hurry to implement the algorithm that we have thought about? Okay, because there can be more than one algorithm that may be present to solve this particular problem. But even the idea that it has come to your mind, how can you even assume that idea is correct? So unless and until you have not tested that idea, you cannot go ahead making an assumption that this idea is correct. You cannot go ahead making an assumption this idea is correct. And we are not going to wait to check whether the idea is correct or not till the time we finish writing the program. Check for the correctness of this algorithm even before we build a program based on it, even before we code it. So we would like to test the correctness very early. So after you have thought of an algorithm, it's time for you to check for correctness of the algorithm. Now you may be wondering, how do you check for the correctness of algorithm? Unless and until I do not write a program and I do not execute the program, how will I know whether my idea is correct or not? We can actually check for the correctness of algorithm even before you write a program based on that particular algorithm. That means even before you start coding, you can check whether idea is correct or not. So don't be in a hurry to implement an idea that has come to your mind. If any idea has come to your mind, first check for the correctness of that particular idea. If the idea is correct, only then we will go ahead making an attempt to implement that particular idea. Even there, we need to think, should we implement that idea if it is correct? That's another question that we'll have to ask. But then, what are the ways in which we can check for the correctness of the algorithm? It is changing, tools are changing. So to check the correctness of the algorithm, we'll learn some new tools right now in this session. But then traditionally, how do you check for the correctness of the algorithm? Because algorithm is nothing but you write in simple English, step by step, I'll do this, I'll do that, I'll do that, I'll do that, so that this particular problem can be solved. Now we need to check for correctness of this algorithm. So let's understand how we can do that. So we don't need to check for the correctness of the algorithm. So there are ways to check for the correctness of the algorithm. So what are the different ways we can check for the correctness of the algorithm? First is dry run or hand run. So let me explain you what exactly do you mean by dry run or hand run. As the name says, dry run, there is no machine involved. Hand run, that means you are going to do it. So dry run or hand run, it's one and the same. But asking the machine to solve that particular problem, execute that particular solution, you have designed an idea. And that idea is what? Simple English you have written. I'll do this first, I'll do that later, I'll do this after this, I'll do that after this. So you have specified one after another what are the steps to be followed. So what you will now be doing is you will be following those steps one after another. And as you follow the steps one after another, what machine would have done the processing, that processing you can do. And as you do that particular processing, and then you'll see whether the result that you get after following that particular algorithm step by step and the expected results, are they matching or not? So if the expected result and the result that I arrived after doing the dry run, hand run, following the instructions of that particular program step by step, if they don't match, then probably your solution is right. I'm saying probably your solution is right. I'm not still providing an assurance that is definitely right. I'm saying probably your solution is right. But then this hand run or dry run is something that should be the first thing that you should do as a developer every time. Whichever technology you're working, whatever kind of program you're writing, if an idea comes to your mind, even before you write the program, first check, express that idea on a piece of paper, walk through that idea step by step manually, and check whether that particular idea is fulfilling your requirement. If it is fulfilling your requirement, then that's a possible solution that is there to solve that particular problem. You could think, not start, you could think about converting this particular algorithm into a computer program. So we are doing the testing even before we run the program. We are doing testing even before we run the program. People have a misconception in their mind. People feel testing is something that we need to do only after we have developed the program. That's very incorrect approach that the people follow. And then over a period, they always suffer with inaccuracies or the failure in getting the work done. So if an idea comes to your mind, even before you implement that particular idea, it is necessary that you check the correctness of that idea. And the first technique that you should follow for a small or large program, whatever piece of code that you write, even in industry, you do not alone develop the entire system. And neither at one time you are asked to do the entire work at one time. At one time, you are doing only one part of the code. So just check whether that particular component that you're designing right now, is it working correctly? Is it giving you the expected results? But not by executing the program, not by writing that particular code. The idea that you have thought as to how will I build this particular solution, check that idea using dry run. So walk through the steps, one after another, walk through the steps and see whether when you walk through the steps, are you getting what you desired? So that's what we will be doing by using concept of dry run. And we will do this dry run very often while we run the program. So first option is dry run. Second is independent expression. Third is structured walkthrough. So let's talk about this dry run slightly more. Sample inputs are taken and algorithm is manually traced. So we are not going to feed this input to the machine. The program will be traced manually by you or by hand on a piece of paper. And the result arrived at is compared to the expected result. So here, what are the inputs that you take are very important. So it is very important that you take inputs whose output you already know. That means you select such input. Suppose you are writing an algorithm to find square root of a number. I'll rather take number as 120, 144. So I know expected answer is 144. So after evaluating, if I trace my algorithm, if I also get 12 as an answer, then I can compare the expected answer 12 with the answer that I have arrived. If both the answers are matching, then probably my solution is right. But if I'm trying to find square root and you take number like 1962, whose square root you already don't know, so whatever answer that you arrive at, you will fail to identify immediately whether the answer is correct or not. Selection of right input is also very important. Take such input during dry run whose output you already know so that you can compare after doing the dry run what result that you have arrived and the expected result, are they both matching or not? And there are techniques to do the dry run which you will master and will be very handy for you while you go through a lot of complex algorithms, especially during data structures and so on. The sample values are so selected whose results are known beforehand. So this is something very important while you do the dry run, because you're going to compare the results that you arrive after manually tracing the problem solution, after manually tracing the algorithm. So what results you arrive, you already know what was expected. So the result arrived and the results expected can be compared. Otherwise, we're always going to face a problem. So that's hand run, or that's also called as dry run. I call it dry run. A lot of text, they say hand run. So I mentioned both the words, hand run, dry run, and so on. And believe me, it's a very handy tool. And during the logic development, we'll always make it a practice that we'll always do a dry run for any problem which is slightly complex. We'll always go ahead doing the dry run where there exists a possibility of certain things going wrong. We'll always do a dry run. The second technique to check for correctness of algorithm is independent inspection. Now, can you guess what must be this concept of independent inspection? What comes to your mind when you use this term independent inspection? Anybody? Yes, anybody guess?
Give our solution to someone else to check.
Very correct. But that someone else is something which is very important. Sairam says checking by friend. I'll not say friend because friend is very subjective matter. My vice president can also be my friend. My junior can also be my friend. I cannot say give the solution that I have designed and ask my junior who has very little experience to check my algorithm whether the algorithm is correct or not. So we normally pass it to our colleagues. Friend, what Sairam is trying to say, friend, others, others, others will be again a vague term. So somebody is not from computing background, we cannot give it to them to check the algorithm. They will not understand anything out of it. So we'll give it to independent party. But that independent person is something that we have to be very careful in selection. Let me tell you how I. That are there working on the same project, they have bias. Say, Prithviraj and Rohit are my friend. So they have a high regards for me. So whatever I say, probably they feel अरे इसका आंसर तो सही होता है. They may not be in a position to check it in a right kind of way. And there is no point in taking this particular solution to the boss, showing that algorithm to the boss, and boss screaming at you, क्या बकवास लिखा है, and having a bad impression in the mind of boss about your ability to think. So boss is out of question. Juniors are out of question. The juniors may not understand the algorithm that you're trying to write, or they may not have that kind of exposure. So colleagues, people who are as good or as bad you are. But even over here, which colleague you should select, that's again very important. Say, let's say Aditya, Ashish, and Bhagyashri and Kaustubh are working in a team. Listen to me very carefully. Yeah? These four people are working in a team. Aditya, Ashish, Bhagyashri, and Kaustubh. These four are in a team. They have been given a problem. Initially, each of them will have difference of opinion. Bhagyashri may think, oh, this can be solved in this way. Ashish kahega nahi this way. Kaustubh will say some different way. Aditya will say different way. But they will have first round of meeting, second round of meeting, third round of meeting. And then over a period, they'll conclude saying, this is the one that will work. Correct? So they will have discussion, first round, second round, third round, and then they'll conclude this is what can be done to overcome this particular difficulty. This is a solution that we can arrive at. And you know what happens? As human, whenever a problem comes in front of us, we try and handle the major issue first. That means the most complex part of it, which is most critical, we focus on that particular thing. Now, since you have spent so much of time thinking about that complex part or the most important part in that entire solution, you have spent enough time, you have done a lot of revision, your total attention was towards that most important part. But in the process, while you're designing a solution, you have taken care of that most important part, but probably you may have forgot about certain small things here and there. Second thing that happens is once you are in a team and after a few rounds of discussion, when you agree on some kind of technique, then all of you start thinking about only one particular way of doing that particular problem. And at times you all, since you are already had done the discussion, when you do the dry run, you do not take those cases where the solution will fail because you cannot think about that idea because you have already thought about certain things and you have some test cases in your mind. In this case, will it work? In this case, will it work? But there could be a completely different scenario where it can fail. And that you have not thought about because if you had thought about it, you could have immediately incorporated it in your solution to that particular problem as well. So passing that algorithm to your colleague who is also part of your team doesn't make sense because then he will test that particular algorithm for the scenarios that you already discussed during your initial round of discussions. To whom should we send this particular algorithm to test? We should send this algorithm to test to your colleague, but who are not a part of that particular discussion of designing the solution. So third party, independent inspection. Those members, those colleagues of yours who have similar experience that what you have, almost similar experience what you have, to them, but they are not the part of your team. To them, you should give this particular solution to algorithm to test. And we, as humans, have one very powerful, what do you say, characteristic, a very powerful skill. Do you know what is the skill that we all have? Which is
Finding mistake of others.
finding mistake of others. We can very well find the mistake with others. Now, if I give this particular algorithm to a person who is not a part of my team, he will immediately tell, rather than checking how correct it is, his focus is totally different. Look, see what happens. If the team member looks into that algorithm, his focus is to prove that idea is correct. So he's thinking about the solution. He's responsible, the team is responsible for getting the right solution. But when I give it to the third party has nothing to do with the solution, correctness of the solution. Their objective is not to come with a correct idea. Their objective is only to find the mistake. Look at the difference. The team members are focused towards coming up with a solution. So even if they identify a problem, the next obvious step that they have to take is to overcome that problem, come with a solution to that particular problem. But the third party who's checking the solution, he is not responsible. The tester is not responsible for giving the solution. His only responsibility is to find out the mistake. So he doesn't have that additional burden to tell what is correct. He just has to find out what is wrong. And we as humans, finding mistake with others, so give that code to somebody else who doesn't have responsibility to suggest a solution. His only focus, his total focus is towards finding the problem. So he will pass on some inputs, which will be such that the possibility of that program failing will be much higher. So he can test in a different way because he was not a part of your initial discussion. He is only concerned about input and output. So he will test your code in a better way for such different scenarios, probably that you haven't thought about. So that's what we do. We send the code for independent inspection. So when I use the word independent, that means the person who's going to test your code is not a part of your team, but who has almost equal kind of experience or expertise as what you have, so that he also understands the algorithm. And then he will test your algorithm, and his focus, his responsibility is not to devise a solution. His responsibility is only to find mistakes. His responsibility is to only check the scenarios where this code will break. That is his responsibility. And we are very good at finding faults with others. So we make use of this human trait to find the mistakes that others have done. So that was the second way of testing the code. Okay. It's called as independent inspection. And the third is third walkthrough. Let's go through this independent inspection. What does it say? It says algorithm designed by one team is forwarded to another team or a member to check for errors. Not the member of the same team, another team. Independent member who is not the part of the development, the team developing the algorithm, is in a better position to identify the mistake. If you pass on that responsibility to somebody who is a part of your team, who has designed the solution, then he's not the right person to come with a solution, come with finding the mistake. He may be the right person to come up with a solution, but not to find the mistake. Give it to the third party. The role of the independent inspection is to identify errors and not to suggest the solution. So if Aditya is an independent inspector, and if you pass the code to him, he is not having the responsibility to come up with if he finds the bug, if he finds the mistake, he will not be responsible for suggesting the solution to that particular mistake. His role is only specific to find only the mistake, not to bother about how this problem can be solved. That's the development team responsibility to identify how the problem can be solved. So that's independent inspection. Human tendency to find the fault with others is put to use. And the third technique that we could use is something called a structured walkthrough. Any guess about structured walkthrough? Yes, anybody? Structured walkthrough, any guess?
Rechecking everything again.
Everything again? So we have already checked it. Huh? What difference will it make by checking it again?
Sir,
tell me.
I think there will be a structured pattern, and
Okay.
according to that pattern, that code or algorithm can be checked.
Yes, anyone else? Structured walkthrough. Okay. Now what happens is you have checked and your colleague have checked. The colleague have almost similar kind of experience that you have. So he is as good or as bad you are. almost similar experience that he has. In this third case, once you are satisfied your algorithm is correct, once your colleagues are identified that algorithm is correct, this is the right time for you to approach your boss. Once we approach the boss, okay, and we give a presentation to the boss about what do we plan to implement. Algorithm, hai na? We have not yet implemented. So you have not wasted the company resource or anything. We are only telling the boss, boss, this is the, you give a presentation to the boss, your seniors. There may not be one person, there could be multiple person. You give them a presentation. This was the POC. And now this is my solution as to what I'm going, this is the problem statement that was given to me. And this is what we have planned that we can do to solve that particular problem. So we give a presentation to seniors. Now, any guess as to why should we give a presentation to the seniors?
They have
to,
already years of experience.
Very correct. So the most important term over here is experience. Okay. You may be very smart, but the seniors may have worked on similar kind of project and they are in better position, not just to check for the correctness. Your algorithm may be correct, but they're in a better position to identify the bottlenecks in the system. Now, bottleneck is a very peculiar kind of condition which exists. Bottleneck are those situations in your solution, failure at which may result into failure of the entire system. Now, what do you mean exactly by that? Let me give you an example to help you understand. How many of you before lockdown had traveled to Mumbai via Pune, from Pune? Raise your hand. Via the express highway. So 2 people had traveled to Mumbai before lockdown. Kya baat hai? Either you are lying or you're not, you're scared of giving the answer. Sairam had traveled, Monica had traveled, Viraj had traveled. Who else? Who's the fourth? To via express highway. Also, how often had you traveled? Is it like I cannot hear you all?
Sir, your voice is breaking. I don't know. I'm not able to hear it sometimes.
Is it? My voice is breaking. Others?
Sir, slightly. Same problem.
Others?
Yes, sir.
Breaking. Or let me know. I have increased the gain. Is it clear now?
Yes, sir.
Yes.
Yes, sir.
Mistake. The gain had got reduced. I have one of the best microphones which are available in the market. One of the best ones. So there is very little chance that it will fail. And I have been using it for years together. Okay. So, Viraj, tell me, how often had you traveled to Mumbai via express highway?
Sir, I don't go much to Mumbai, but 4 or 5 times.
4 or 5 times you have traveled. Let's take a scenario. How many lanes do you have on Mumbai-Pune express highway? One side? Lanes, of course, lanes.
Total 4 lanes.
Three, and one is for emergency. I mean, if you want to park
There are
the
4
car.
lanes. That means there are 4 lanes. Okay. Now let's take a scenario. So there are 4 lanes which are there. Huh? One side we are talking about. We are not talking about both the sides. We are just talking about one side. So let us take a color and we'll say this is the first lane. This is the first lane. Okay. Then this is the second lane. Then this is the third lane. Third lane, and this is the fourth lane. So total there are 4 lanes. Okay.
Sir,
Suppose you are 5 हो गए क्या बात कर रहे हैं ये 1 हो गया ये 2 हो गया ये 3 हो गया 4 ये हो गया क्या बात कर रहे हैं okay 5 lanes but 4 lanes है okay so we have these 4 lanes or I could have just drawn it in a different way but I hope you understand this diagram. The other way I could have drawn some shapes. Yeah, I could have just said this is the first lane, this is the first lane, And then this is the second lane. I could have just taken this, I could have repeated 4 times. Right? Okay. Let's see, I thought it will get copied. It's not allowing us to copy it. Then probably I have to draw. This is the second lane. Then there is a third lane. There's a third lane. So that's better diagram than what we did earlier. And then probably this is the fourth lane. So these are 4 lanes. And these are 4 lanes on which you can drive towards Mumbai. You are traveling from Pune to Mumbai. And say you are at Talegaon. You are at Talegaon. Oh, not this. You are at Talegaon. Here is Talegaon. You are at Talegaon. And at lane number 1, there is an accident that happens. So there is now an accident that has occurred in lane number 1. So lane number 1 में यहाँ कहीं तो accident has occurred. So what will you do now? आपको algorithm design करना है so that the traffic is still smooth even if there is an accident. So how will you ensure the traffic is smooth even if there is an accident? Will you go over that accident? That means a car accident, you will fly over that accident and then proceed further. The cars which are coming, can they do that? So cars are coming from here. Will they fly over that particular accident? So what will you do?
Sir, we'll
Redirect
put
the
that
traffic from the second lane.
Second lane. The logic was very simple. If there is an accident on the first lane, we'll redirect the traffic to the second lane. So this traffic which was going here, so that traffic I could redirect onto the second lane, correct? That traffic we could now redirect to the second lane. So if there is an accident on the first lane, earlier the traffic was moving, but now there is an accident on that particular lane. So we redirect the traffic to the second lane. That's how simple and straightforward the logic is. That's how simple and straightforward the logic is. Now you are at Talegaon and you cross Talegaon and you move slightly further. What's the next thing that will come across after Talegaon? You stay in Lonavala.
Lonavala.
Between Talegaon and Lonavala.
Vadgaon.
Suppose you come across. Okay, you come across Vadgaon. Okay, you come across Vadgaon. At Vadgaon, there is an accident again that has occurred, but that's on lane number 2. So you come to Vadgaon and there is an accident in lane number 2. Now what will you do?
Yeah, you can
Again,
use
switch to
other
lane
two.
number 1.
Again, switch to lane number 1. Why not to lane number 3?
They're all usable, except that second lane.
That's not right. What Rohit said is correct.
We will
Any
not
reason?
disturb, sir. We will not disturb lane third, sir.
So in that case, if I go to lane 1, then we'll disturb lane 1 also, no? Why
Yes,
not?
sir.
Because Talegaon ke baad some people must have moved to lane 1, na? That's the reason I put. There was accident at Talegaon. Does that mean till Mumbai nobody is going to travel on that lane?
No.
You will be traveling, na?
Yes.
So there is a traffic that will be there on this lane. यहाँ लोग travel कर रहे हैं. Any specific reason? You have to have sound reason. Rohit गलती से बोल दिया था या सोच के बोल रहा था? Lane 1.
मुझे लगा वो बाकी के 2 लेन से इधर से ऑपोजिट गाड़ी आएंगी इसलिए
Lanes towards Mumbai. Mumbai to Pune, we are not showing. These are 4 lanes which are going towards Mumbai. Okay, I'll tell you the reason. Why would I write a logic where I'll go to lane number 1 rather than go to lane number 3? Are you aware? The innermost lane is the fastest lane.
Yes.
So if I'm traveling and I reach over here and I see an accident in front of me, it's a high risk to move into a fast moving lane than to move into a small, switching the lane and going to a slow moving lane.
Yes.
Okay, so it would not be advisable to go to the higher lane number. It would be advisable to go to lower lane number. So if there is an accident lane number 2, we would rather advise, write a logic to move to lane, switch over to lane number 1 rather than going to a high moving speed lane that is lane number 3. Got justification why not lane number 3 but lane number 1? Everybody?
Yes.
So there
Yes,
has to be
sir.
justification behind it. Huh? Now you leave Vadgaon and you come further. Tell me some other place.
Kamshet.
Kamshet. So you reach Kamshet, suppose. So you reach Kamshet and you realize there is an accident on lane number 3 at Kamshet. Okay, so what will you do now? And now there is a traffic which is moving and it realizes there is an accident lane number 3.
Switch to lane number 2.
Switch to lane number 2. Okay, there was no choice. But in the first case, you had to move to a fast moving lane. One पे accident है तो we cannot go to switch to lane number 0. So there
Yes.
is that risk, but that's not that fast. But here you don't have a choice. Here we have a choice. You could have gone to the fast moving train where some all these super fast cars are moving and then take a risk. Rather, आपसे जो slow चल रहा है, in that lane you will shift. So you'll go to lane number 2. Likewise, you come further just after Kamchet, you come some further and there is an accident over here. So where will you move?
Lane 3.
Did you realize there's a pattern as to how do we move? Can you anybody identify?
Current lane -1.
Current lane -1, but that will not be the case for the lane number 1.
Yes.
So if the lane number is not 1, then for any other lane, where if there is an accident, always redirect the traffic to a lane number which is lesser
Lower.
than the current lane or lower lane number. Okay,
Yes.
that's an algorithm that we have come up with. Least special case would be for lane number 1. So algorithm is perfect. So anytime anywhere accident occurs on any lane, we can still manage the traffic. Yes or no?
Yes.
Yes. Sir, what if दोनों lane पे एक साथ accident n-1 वाले lane?
Then you can move 2 lanes down because suppose यहाँ भी accident हुआ है और यहाँ भी accident हो रहा है. Sorry, there are 2 lanes on which the accident has occurred. Okay, and that could be very rare where 2 lanes accident has occurred. But अगर ऐसा हुआ भी है, so you because you saw an accident front, you move to the lower lane. But suppose you are here and there is an accident, you move to the lower lane. You realize there also there is an accident, so you will go to the higher lane, lower lane. So you always go on shifting to the lowermost lane till the time you do not find the free traffic. Okay. Another सारे lane पे there is an accident, you have no choice but to stop.
Yes.
The time the traffic has not been taken care of. So we have, these are not all the cases, but to some extent we have handled this traffic problem. This accident problem is to some extent we have now handled. But now, while it looks like we have handled this particular issue, if you have really traveled from Pune to Mumbai, there is one peculiar scenario that you come across at the Amrutanjan Bridge. What is that you come across at the Amrutanjan Bridge, if anybody remembers? Now that has been demolished, but before the lockdown, you had the Amrutanjan Bridge at Lonavala. So what was that typical thing at Lonavala at Amrutanjan Bridge? Okay.
Sir, getting two roads were getting connected.
2 roads were getting connected, rather 4 were getting connected, merging only to 2. So these 4 lanes was merging into only 2, and even within that 2, one was a smaller lane and one was a bigger lane. One was only for cars, another was for truck. Okay, so that at that Amrutanjan Bridge, there was a difficult situation that was there. One lane was so narrow that the truck cannot go through it. Other lane was so large, only a truck can go through it. So the 4 lanes converged only onto 2, and that was for a very small section, not more than 50 meters. But that was the problem that was there. That was the problem. And then again, it would move into 4 lanes again. So there was no issue later. Again, they would move into 4 lanes, but there was a problem here. Now, one lane was for truck, other lane was for car. Okay. Now what happens is, and the truck with that big trolleys are traveling, and what problem that Ashish was thinking, now you come across that particular problem. There's a truck that fails and that falls across this particular 2 lanes. So ये truck है, वो ऐसा tilt इस तरीके से हो जाता है that it falls across. यहाँ से उसका container गिर गया. The truck is here and the container is on this the car lane. क्या करोगे?
Sir, you will have to stop until it gets cleared.
You have to stop. So the entire movement of the traffic has come to an halt.
Yes.
Right. So this area of our program, we call that as bottleneck. इसी को हम लोग bottleneck कहते हैं. This is the bottleneck of my system. ये मेरे system का bottleneck है. Because failure at any other problem area could have been handled in such a way, but over here, if there is a failure, that will result into failure of the entire system. But you may be wondering, why am I talking about this concept of bottlenecks? Why are we talking about bottlenecks? The reason is very obvious for us to talk about bottlenecks, because seniors with their experience are in a better position to find out such situations in your algorithm as well, where there is a bottleneck. Now, if there is a bottleneck, if they identify that particular bottleneck, and you, since you have not worked on similar kind of systems earlier, you may not think about such a rare situation. Pune Mumbai socha, so everyone was thinking about 4-lane highway. But there was a situation which is very rare. Now you don't have that situation because that problem has been taken care of during the lockdown. They demolished that entire thing. And that situation was so tedious because why couldn't they take care of it earlier? I'll tell you. When Amruthan Bridge was narrow, and on top of it, there was a train which was traveling. And ऊपर से train जाती थी, नीचे से ये जाता था. So such a complex scenario. That means you have to destroy that bridge. You also have to take care of the railway moving above it. So that's the reason that thing stayed back for the last 15 years. And during lockdown, they got enough time to improvise, make way for the train, and also take care of the traffic. They couldn't keep the Pune Express Highway down for 1 month, 2 months, other time. But lockdown gave them an opportunity. So demolish that entire railway bridge, the roads also, and they reconstructed everything as ideally what should have been done. But with newer technology, they could do it, which they could not do 890s when that road was constructed. So that was a bottleneck. Now seniors with their experience can identify such bottlenecks which are there inside the system. They could also identify the situation where under a particular workload, a specific load, that program could fail. Stress, we call them stress test. So there are testing that we do later, but they can identify with their experience. And now if they identify, we should be thankful to your senior because he has identified something, a problem that you could not even anticipate. आप सोच भी नहीं सकते थे that they have identified. But then there is one thing that you should always take care. Never ask the senior for the solution for that particular problem. Sir, now that you have identified the problem, can you also please tell us how this problem can be overcome? That's something that you should not be ever doing. Neither expect the senior to give you a solution, neither ask the senior for the solution or even the hint. Because giving hint, we already know what are the issues. So if the senior insists, that's a different case. But you should not ask for the hint, neither the solution. You should be thankful for the senior for providing, for identifying that particular bottleneck in the system. You can come improvise with some other design. Then you can come with an idea that before Talegaon, before Lonavala, I'll redirect the traffic to Old Mumbai Pune Highway. I'll skip that entire bridge and via Khopoli, I'll again come back to the express highway again. You could think about an algorithm as to how that problem can be taken care of. The traffic has to be redirected. You cannot stop the flow of the traffic. Algorithm can be improvised. You can come with techniques to solve that particular problem, but never expect senior. But seniors with their experience can identify such situations that may result into failure of your algorithm. Give the presentation to seniors because that will save your time that would otherwise waste in implementing an idea that was actually going to fail. And there could be multiple cases where that algorithm may be failing. So get it checked from your seniors. And it will not take them much time to understand what are you trying to do. They may have worked on, or they definitely must have worked on similar kind of situations earlier. So they're in a better position to identify what possible mistakes exist in your idea. So get that particular solution checked from your seniors. And that was nothing but structure walkthrough. Presentations are made in front of seniors or peers. Seniors with their experience are in a better position to identify bottlenecks in the system. And what is bottleneck? It's an area within the solution model which is critical. Why is it critical? Because failure at which may result into failure of the entire system. So a critical area aapke program ka. And seniors with their experience can identify such critical areas. Once that area has been identified, think about a solution as to how this particular problem can be taken care of, how you can overcome this particular thing. That you are smart enough, you have a thinking mind, so you can think about it. But at least identify what seniors will always have edge over you in one way, and that one experience, they will always have more experience. You may be very good in the technology, but they have worked on similar projects earlier in the past, so they have better exposure. So make use of their experience to identify such bottlenecks in the system. And remember, these 3 steps were implemented early stage when that idea is only on a piece of paper. So investing our time implementing that code. So it could be like architect. Remember my example that I gave you yesterday. Architect is, you have given the contractor a plan to task to build the building. And then while he's about to build that particular building, he builds that entire building, and then you realize that building is not for as per the client's requirement. And then he demolishes that entire building and then reconstruct the building. It would have been better, he would have shown you the plan first to the customer. If the customer approves or even disapproves, the cost of making changes in the plan is far less as compared to cost of making the changes in the structure that has been created. So you can revise this particular plan as many number of times. Okay, because cost is hardly anything, revising the plan. But implementation ke baad, if you are asked to make a change, that is a terrifying kind of experience that a developer will face. Because you have already done so much of efforts writing a code, and then you ask him to rewrite that entire code. That could be sheer waste of time, efforts, and everything. So give a presentation, check it on your own, get it checked from your colleagues, show it to your boss. And if it passes through all the stages, only then think about implementing that particular idea. So don't be in a hurry to implement the idea. So that's testing of algorithm. Have you all understood this? Yes. Everybody, quick feedback. Ashish, any query? Ashish Patel, okay.
No, sir.
So now that you have got your algorithm tested, what could be the next step? Yes, anybody? Algorithm to test kya hai? You are very sure this algorithm is perfect. Your boss also said, good work, it will work. Come on, what would the next step be now?
Implementation.
Implementation. Who said that?
Sir, Aditya.
Aditya said that. Okay, Aditya said implement that particular algorithm. What do you mean by implementation?
Sir,
Yes, anybody could answer. What do you mean by implement?
Start working on it.
Start working
Start
on the
writing
piece of-
program.
Start writing program. That means you had an algorithm on a piece of paper. Start converting, start coding, converting into a computer program. Yes or no?
Yes.
yes.
And that we are doing only after checking the algorithm is correct or not.
Yes.
Yes.
Okay, and
Yes,
that would
sir.
be foolish on your part to do that. Why? Because this was only one idea that had come to your mind, that you got it tested, that you know it is working. It is a correct solution, may not be the best solution. So unless and until, yesterday, do you remember why people fail? One of the reasons was you have not thought about alternatives. Here you have not thought about alternative way to solve that particular problem. You have only thought about identified the correct way to solve the problem, not the best way to solve the problem. Now, whether this particular solution is best or not, I asked you a question yesterday whether Aditya is tallest in the class and he's the only person sitting in the class, or you're not make him stand with the next fellow in the class. How will you know he's tallest? So unless and until you do not compare one algorithm with the other, you'll never be in a position to know whether the idea that you thought is good or not. Yeah, is the best idea or not. There could be a number of ways that particular problem could have been solved. So the important thing over here is to select the best algorithm. Now, for you to select the best algorithm, you should at least have two algorithms that are there that could solve the same problem. So what are the criteria to select the best algorithm? It's not like I like Ashish, so Ashish ka algorithm maine select karna hai. That could not be the case. And I don't like Viraj, so Viraj ka algorithm hai to reject karna hai. No, there has to be some parameters based on which we will decide whose algorithm is better, which idea is better, and based on which idea is better, that we will use to implement. What are the criteria that one can think about? We have not written the code, but then we have written it in simple English-like language. So we can check whose algorithm reaches the result in least number of steps. Viraj's algorithm, although I don't like him, his algorithm is only about 50 lines. And I like Ashish, but his algorithm is 75 lines. After 75 lines, I'm going to reach that particular, I'm going to get the answer. And Viraj after 50 lines, I definitely have to give consideration to Viraj algorithm, because less the number of lines I write, less the chance of error also to commit. So the steps count is also a very important criteria. Not the only criteria, but important. Rohit also has implemented the algorithm. So what took Ashish 75 lines, what took Viraj 50 lines, Aditya writes in 5 lines. Aditya may have written in 5 lines, but nobody amongst us can understand that idea the way he has written that particular instructions over there. So although it may be the shortest one, the number of steps may be as less as possible, but if it's difficult to understand and difficult to maintain and difficult to implement, I'll rather ignore that particular idea. So idea should be such that it is easy for others to implement. In English, it may look very short, what he has written. But when you go on to write it, if it is going to increase the complexity of a code, and code is always to be maintained by somebody else in future, is it like you develop the code and throughout your life, you're going to be in the same company explaining the client anytime the problem occurs, you're going to go and help as to how that problem has to be solved. You're here in one company today and tomorrow you're in some other company. Somebody else is going to look at the algorithm, the problem that your solution that is going to be designed. And if they fail to understand that algorithm is of no use. And one of the most important characteristics is correctness. You cannot call that solution an algorithm unless it is correct. It has to be correct. And last is unambiguous. Confusing nahi chahiye. If it is confusing, it may be correct, but if it is confusing, I'll rather ignore that algorithm where there is a possibility of the maintenance guy making some inappropriate changes to the code. I'll rather ignore that particular algorithm. So it's very important for us to have some criteria. These are not the only criteria. I just listed on few criteria based on which, so it should not be biased kind of opinion. Huh? I like him, I don't like him. No, not, or this is the past experience. Rohit's code last time was good. That means this time also it will be better. No, no bias. If given it equal treatment. So when we have multiple algorithms, 4 of them have given ideas, and I have to select one of those ideas. So you put down your criteria based on which we are going to decide which algorithm is better. So there are some simple ideas that criteria that we have listed over here. There can be a few more criteria, but these are the first criteria that should come to your mind, which is short, even if it's short, which is easy to understand and implement, whether it is correct or not, whether it is unambiguous, confusing to nahi hai na. So these are the things that you should keep in mind while you're selecting the best algorithm. Now that you have selected the best algorithm, then we'll implement the algorithm. So don't be in a hurry. If one idea strikes your mind, you will start writing code based on that idea. Check whether idea is correct or not. Check whether idea is best or not. So once you're sure that idea is perfect, best, not just correct, it has to be correct, but it is better than other ideas which we have thought about, then you can think about implementing that algorithm. And implement is nothing but writing a program. It's translating that English-like statements into a program using some language that you know. So programs are written using some couple of programming language. So you will be knowing some language. So you will translate the algorithm that you have into a programming language, into a code, as we call this. So here programming is coding. And coding is nothing but translation of algorithm from user understand format like English or pictures to machine understand format. So we'll translate your code into a format. Coding is what we are going to do now. In this case, programming is everything, but here in this case, programming is coding. You're going to write a program. That means you're going to code. That means you're going to translate that particular algorithm into a computer program that the machine understands. So programming is translation of algorithm. Rather, I should say coding is translation of algorithm into a computer program using syntax and semantics of a programming language. Let me make that change. Let us use the right word. Let me say coding instead of saying programming, because programming encompasses a lot of things. I'll say coding. Coding is translation of algorithm. It's very important. So I'm saying coding is translation of algorithm into a computer program using syntax and semantics of some programming language. So you may have learned C++, you may have learned Java, you may have learned whatever programming language that you love. Okay, Ruby, Scala, whatever it may be, Haskell, and you use that Haskell to convert your idea, or even a language of yesteryears. 1953 में एक language आया था, language called as Lisp, LISP. And believe me, with this advent of AI, 1953 का language has now gained momentum. So idea was that idea language came in 1953. All these it was almost dormant. Nobody even looked at it. And now with the advent of this AI, that language has again come to prominence. So if you want to work in AI, one language that you will have to also gain expertise in is Lisp. Okay, find out the reason why Lisp is popular in AI domain right now. But this language is of 1953, way back, even before language C, it was created. C came in somewhere around mid-60s. So 1953 ka language, 50s ka language. But then, point is like whatever language you know, whatever language is appropriate for that kind of problems, that language you should use to translate your algorithm into a computer program using syntax and semantics of a programming language. Syntax are rules, okay, like grammar, and semantics is like the words, vocabulary that the language provides. using the rules and the regulations of that language, we will translate the algorithm into a computer program. So that was implementation of the algorithm. Now that you have implemented the algorithm, what should you do next? Yes. But to implement the algorithm, you'll have to make use of some language. Yeah? And one thing you should always be wary about, you will not use the language just because you know that language. Viraj knows Python. So whatever problem comes in front of Viraj, you'll always solve through Python. That's a bad thing to do. Rohit knows C++. So whatever problem you give to him, you'll always try and solve with C++. Very bad. You have to use an appropriate language. Because some language are good at some part. They have some support for some kind of operations. Like I gave an example of Lisp. It's a very old language. None of you know it. That does not mean if I'm doing AI, I will not learn it just because it is old. If it is a better language to solve those kind of problems, I'll rather learn AI. And if I cannot learn, I'll hire Rahul, who is good in that language. So we can hire a resource or we can learn, but use the language which is very appropriate for that particular kind of problem. So for different problems, there are different languages which are appropriate to use the right language for the right kind of solution that you're trying to implement. So selecting the programming language, some language are more efficient for certain tasks. Like I said, Lisp is better than maybe Java for AI programming. All languages handle input, arithmetic processing, input, output, other standard function. Logic can be executed in any number of languages. But then, although I could write the same code in Python and C++ and Java, but then writing in each of that language, there will be a difference in performance, in space, the memory that it takes, and so on. So some language are more efficient for certain tasks as compared to some other language. If you're looking for speed, think about a language like assembly, C, C++. If you're looking at simplicity, think about language like Python. But if speed is critical, you cannot work with Python. You'll have to go in for C, C++ and implement that more complex idea for the performance. And then we'll write those instructions. Planning generally more difficult than coding. People feel coding is difficult. So I cannot write code. More difficult than coding is the planning. And that is what we have done till now. Coding is the easiest job to do, provided you know what is to be done. When you do not know what is to be done, you learn as many number of languages that will not serve any purpose, because kya karna hai language par ke wahi pata nahi hai. So what will you do even if you learn the language? So first try and understand the logic, or try and build their ability to come with the solutions. So if you can build the algorithm, then it hardly takes any time to implement the algorithm. Language ka support is also very good. Documentation is available. So you can just see how to do it in C. I know if I have to print a message, if it's C, I'll search, C में print करने के लिए क्या है, printf है, C++ में print करने के लिए क्या है, maybe there is putS, or if there is suppose cout, तो Python में क्या है, I'll say there is print, Java में क्या है, there is system.out.println, you could find out. So translation is not that difficult. Algorithms are difficult. Ideas are more important. So planning is more generally difficult than coding. And people, youngsters like you, worry more about coding than planning. So worry more about planning than coding, because coding is really very simple. You don't have to bother much.
Sir, but what if employee only knows one language?
Then he's not good enough for multiple tasks. He's only good enough for some tasks where that language is appropriate. And these are the people who are chucked out of the company, early, when they do not have projects on that particular technology. So when we say, the company is firing these number of people, because nowadays in the market, the margins are very thin. Companies themselves are working at a very thin margin. They don't have enough of profits to keep a bench strength, which is what they used to have 15, 20 years back, before 2000, like in early 2010 and other things, or 2015 ke baad, when there was a boom time. So you could actually keep a lot of people on bench. But today when the margins are thin, they will not have a resource which is just sitting idle. And if you do not know, if the team needs some skill, they will either tell you, learn this and be ready. And if you cannot learn, you say, I cannot learn, they'll say bye-bye to you. We have Sairam. How is the situation, Sairam, in your company? If you do not know a technology, what will happen?
They won't ask you that, do you know or not?
Ask you, first case. I'll give you an example. I had a student of mine.
I have an example of mine only.
Pardon?
Till the time I have joined Veritas, I didn't know only about C and C++. And once I entered the Veritas, I have been given work on shell scripting, Perl, some Python script. Directly, they have given me work, and that too on cross-platform. Since I am working on Linux, 2 flavors of Linux, 2 flavors of Solaris, and 1 flavor of AIX as well. And not doing anything of everything.
Things that were given. But we completed shell script. If you have missed out on those things, just have a look at the shell scripting that we have done. Fundamentals. We done a shell scripting to a larger extent.
Yes.
Now, look at this. He said they did not even ask him, do you know it or not? And what would happen if he says, sir, I cannot do it?
You can't say. We
If you
can
say-
discuss about this here only, but we can't say.
But if you say, then what would happen?
At least they will directly say learn and do the task. But anyhow, you have to do the task.
So there is no option of not doing it.
Yes, yes, yes.
That's what I'm citing an example.
Yeah.
A friend of mine, not actually friend, he became a friend when he became my student. He was working in Capgemini. He was working on mainframe systems. He was leading a team, project manager tha. Look at the position, 15 years of experience, project manager, working on mainframes and COBOL. And then that project that was there for US client that got over. Now that company decided to switch over to Java. He was given 1 month time with 15 years of experience in the same company, being a project manager. He was told in 1 month, next month you have to manage a Java team. And he had never in his last 15 years touched Java ka J. He was good in mainframes, COBOL and AS400, and those are the technologies that he was good at. And he was told, Java team manage karna hai. He said, I cannot. They said, then either we give you 1 month, 1 month is good enough. Either you manage the team or you put down your paper. And he was forced to put down your paper because he couldn't complete Java in 1 month to an extent that they were expecting. But he was courageous enough. He came down, he came at Impetus, he learned the entire Java. It took him another 6 months. And then he applied for, because he had management experience that was very good. Now he knew Java also. He completed certification within 6 months. Both the certification he completed. And then he went to Persistence. And then he's today managing Java team in Persistence. So learning language is not that difficult. He knew the task, but then learning language is important. You have to master the skills. And you at times get very late. Java is like vast. And if he has to manage a team, he was expecting to know in and out. He was having some fear about it. So he spent some time. But then he mastered it. And within 6 months, he was again back at a better position with a better hike in another company managing Java. So, where is this question? Viraj, you don't have a choice. Either you do it or you leave it. Leave it means chhod ke ghar jao. And a lot of times when people do not show that willingness to adopt, learn, they are the people who are asked to leave. So when they have to decide kisko rakhna hai, kisko nikalna hai, they will always check whether you have that attitude towards learning or you don't have. Everything is recorded. Everything is, they will all have your service record book they will have. And they will point out and tell, oh, June mein aapne kya kiya tha? What happened? You will keep the entire story with them. You don't have a choice. Either you learn or you quit and join another company which is working on the same project, technology. Is that okay?
Yes, sir.
So we have, anybody wants to say something? So step 6 was what we had talked about, implement the algorithm. When we implement algorithm, that was writing a program. Now that you have implemented the algorithm, we have created a program based on it. What is the next step that we should be following? Any idea, anybody? Okay. What did we do next?
Sir, n number of test cases.
N number of test cases. That means test karo. There are different kind of tests. Look, your algorithm was perfect. But when you're translating that algorithm, say you write an algorithm and Bhagyashree is implementing the algorithm. So there could be some misinterpretation of what you're trying to say and what Bhagyashree understands. So your algorithm was correct, your colleagues had checked, you had checked, your boss had checked, but your team who goes on to implement, there could be some mistake that may occur while even they're translating that algorithm into a computer program. There could be syntax errors which the developer can take care of. There could be some logical errors that may get introduced. There are so many different kind of problems that can get introduced even after while you're trying to translate that algorithm into a computer program. So second phase of testing is what we'll now initiate. So we'll again go ahead with the testing after you have written this particular program. So test the program now, not the algorithm. Algorithm is already tested. Now we'll test the program. Test the program for correctness, whether after translation, the code that we have written, is it achieving the same thing that we are planning to achieve? Execute it to the sample data and check the result. Remember, during the dry run, we had taken the sample data. Now take those sample data and see whether the code also gives you the expected answer. Identify logical errors and correct them. So logical errors are the most difficult things because there the program does not stop. It gives you answer, sometimes correct answer and sometimes wrong answer. You're wondering how can it happen sometimes correct answer and sometimes wrong answer. Let me give you an example, a very simple example. So you write a program for doing addition of two numbers. Suppose you'll never be asked to write such a simple program, but कहीं तो addition of two numbers है, तो उसका logic क्या रहेगा? क्या करोगे कोड में? Yes. So you may have written some function, correct? You may have written some function. That function could be addition. Okay. Suppose we are writing the shell script. So we say function add, and whatever are the parameters that we pass, that will return. So I will say return $1, isn't it? $1 plus $2. Yes or no?
Echo.
Yes, sir.
Yeah. Will I put this in square bracket?
Echo करेंगे ना?
Echo करेंगे. Okay. Return से issue आएगा. I'll rather say echo. And echo if I put, then I'll also have to put this in. Okay. So I'll evaluate in this particular fashion. So I echoed this particular result, and those are not aware of shell scripting. Then what I would rather do here is say I'm writing a code in Python or C++ or something like that. We'll have function add, which will take int n1, comma int maybe number 2, n2, ऐसे दो. And here we could just say return n1 plus n2. Now suppose you have passed two numbers as 10 and 20. So what will this function return us?
30.
30. So you have tested the code expected answer was 30, 10 plus 20 is 30. Okay. So if I pass two numbers as 2 and 2, what is the expected output?
4.
4. Hai. So you know the solution is working right. But then Monica, while she's implementing the algorithm, she made a mistake. Instead of putting this as plus sign, she mistakenly write it as multiplication. Function was for adding. And now she's testing for a code like 2. So 2 into 2.
4.
And you're testing code addition, and you'll pass two numbers, 2 and 2. You got answer as 4. You are under impression code is working correctly, 2 plus 2 is 4. But actually what has happened? It has given you multiplication. Tomorrow when you pass 2 and 5, expected answer was 7. 2 plus 5 का answer was 7. Addition है तो 7 चाहिए था. And what will end up getting?
10.
10. Okay. So for some input it may give you right answer, and for some input may give you wrong answer. So there is a logical mistake that is there. You fail to correctly translate the algorithm. Plus की जगह आपने multiply कर लिया. So somewhere in the equations plus हो गया, minus हो गया, and these are very difficult to identify because compiler doesn't know what you are trying to do. So compiler will not be in a position to identify such mistakes that you may have done. It is your responsibility that you do not commit such mistakes. It is your responsibility that you do not commit such mistakes. So it's very important for you to identify or ensure that there are no such logical mistakes if there are. And if there are, you have to correct them. There is no other choice. Choose the test data carefully to exercise all branches of logic. Okay, this is what Ashish was trying to say in a crude way. मैं उसको अच्छी words में डाल रहा हूँ. Look, there are different situations in the program. If this is the case, do this part. If that is the case, do this, and so on. Say you are trying to find the square root of a number. तो square root का logic है, but negative number आया तो अलग बताना message. Positive number है तो अलग है. There may be a number of conditions that it has to follow. So take the data such that it will check for all the kind of all the kind of cases. That means this branch of the logic should also be checked. That branch of the logic should also be checked. All the scenarios should be taken care. So don't just go ahead with one input set. Just say in the last example, a plus b करना था, Monica by mistake said into, you took only one set of values 2 and 2 and you reached to a conclusion answer सही है. अरे but take 2 and 7, see what is happening. Are you getting 14? Are you getting 9? So take all the scenarios, and there could be a number of branches in your code. The flow may be this way, that way. Make sure that you check all the scenarios that are there in your code. So have several text cases, not just one. There are 3 types of errors that may creep in. एक है syntax error. You don't have to worry about syntax errors because your machine, your program, machine, compilers, linkers, they will tell you, oh, either there is a mistake in the way you have to use the command. Command was print, and by mistake you said printing. And machine will tell you there is a mistake. So syntax errors are the most common, but you don't have to worry because compilers and linkers will tell you about them. So they can be identified very early. The most difficult are logical errors because the program gets compiled. Some programming language, say Java. Java is something that you and me will understand. Machine doesn't understand. So Java code is translated into a format that the machine understands by the Java compiler. So the compiler can only identify the syntax errors. Compiler will not identify mistakes in the logic. Okay, they are not that smart to identify अरे आपका logic गलत है, addition लिखा है function का नाम और अंदर आप multiply कर रहे. Compiler will never report to you as long as that plus and multiply both are valid symbols. So now these logical mistakes are very difficult to rectify. Sometimes we find it better to rewrite the code than to worry about find out where exactly the logic is wrong. You have to, at most precaution should be taken that you do not commit logical errors while you translate the algorithm into a computer program. And third are also dangerous, execution error. A simplest kind of scenario could be like program runs, it doesn't stop. Yesterday we said the program should get over in a finite amount of time. There should be some time frame. Here it gets into infinite loop, it doesn't stop, it gets hang. So those execution errors are also to be taken care of. Syntax errors, logical errors. The program gets executed if there is logical and execution error. Program doesn't stop when there is an execution error. Program gives you answer that may be correct or wrong in logical errors. Program doesn't run. You cannot execute a program when there is a syntax error. So syntax errors are the easiest and the most common, but very easy to identify and rectify. Because compiler tells you which line is the mistake, what is the mistake, what is the solution for that particular mistake. Compiler tells you everything. So it's very easy to rectify. But that's not the case with logical errors and execution error. You have to take utmost care. कभी हम लोग less than लिख देते हैं, where we should have said less than or equal to. Now, how will the compiler know whether you really wanted less than or less than or equal to? It is for you to take at most precaution when you're translating the algorithm into a computer program. So there are no such errors that creep in into your program. So that was testing of the program. Now that you have completed the testing, what is the next thing that we should be doing? Any guess? Yes. Just to go to the point, testing में क्या syntax errors? Errors due to the fact that the syntax of the language is not respected. That means you do not follow the rules of the languages. Compiler can identify them. Semantic error due to improper use of program statements. Logical errors due to the fact that the specification is not respected. Addition करना था, multiply कर दिया. Less than equal to तक जाना था और आपने less than तक specification has not been met. Syntax errors, these are the easiest to find because they are highlighted by the compiler. They occur when the program does not use correct grammatical rules of the language. So don't bother much about them because compiler will tell you what the mistake is. If the program has syntax errors, it cannot be translated and the program will not be executed. So there is very little risk that client will suffer any problem because of the syntax error. Because program will not run if there is a syntax error. So you don't have to bother much. Say sometimes unterminated string, semicolon missing, C++ हम लोग semicolon लिखना भूल जाते कभी कभार. Double quotes start करते हैं, double quotes खत्म करना से भूल जाते हैं printf वगैरह में. So those are errors that can be very easily identified. Semantics errors. Most of the semantics errors do not generate compiler warnings, but the program runs and does not work correctly. That's serious. Infinite loop है, misunderstanding the operator precedence. पहले multiply होगा या addition होगा, आपने order गलत दे दिया. Code inside the loop that does not belong there. Some statement should be present inside the loop, you write outside the loop. Some statement which should be outside the loop, you write inside the loop. Compiler can identify those things. These are the hardest error to find as they do not halt the program. These are mistake in the logic. आपने problem ही गलत समझा है. Program with logic error will often compile, execute, and output results. However, at least sometimes the output will be incorrect. And several times the output will be correct, and sometimes the output will be incorrect. That's very dangerous. Error message will generally not appear. If there is an error message, good. But if there is no error message, what can I do then? If there is logic error occurs, it makes the logic error very difficult to locate and correct. So you have to take utmost precaution that there are no logical errors in your system, in your logic code that you write. So testing was something which is very important, so that we identify all these kind of errors. So these errors that we have written, so what we did is we are testing the program, and with testing we identify all the kind of problems that may be existing in the solution, the algorithm that you have implemented. And once that particular syntax, logical, semantics errors have been identified, then you can proceed towards what? What would the next step be?
So document.
Documentation. Okay. When we talk about this, there are different types of testing which are done. Let me just give you, we talked about errors. Let me also give you a brief about some commonly used terms when you talk about testing. You will very often come across a term called as black box testing. What do you mean by black box testing? This diagram will help you to understand it. In black box testing, we don't even look at the code. Listen to me. You don't even look at the code. Code is a black box. We don't look into the code. And we see the output. So we send the input. The program has promised that I'll find the square root. So we'll only look at the output. We'll not look into the logic as to how that operation has been done. Okay, so that's called as black box testing. Is a method of software testing that tests the functionality of an application. It is not going to check how that result was arrived at. It only checks for a given input whether the expected output was arrived or not. It's a black box, so you will not see the code. You will ignore what is happening inside. You are more concerned whether for this 7 plus 2 answer 9 aa hai kya? That's okay. How it is doing, what logic it is applying inside, I'm not really bothered. That's black box testing. So we do not see the quality of the code. We only see for all the different cases, do you get the expected output or not? That's black box. So mark this word black box. It's a covered box. It's a black box. So we don't see inside it. We don't see the logic of the program. Algorithm nahi dekhenge. Hame input or output dekhna hai. For this input, that is the expected output. That's it. Okay, we are not checking for the quality of the code. That's black box testing. Then there is something called as white box testing. एक है black box, दूसरा है white box. It's a method of testing software that tests the internal structure and working of an application. That means you will now go into that code and see कैसे काम कर रहा है. The program source code is tested without running it. We only need to examine and review the code. That means Rohit writes the code and Bhagyashree is reviewing that code. Bhagyashree is उसकी team lead है, so she goes to the code to see without running the code. She will go to the code to see whether the code is written as per the guidelines of the company, whether the formats are correctly maintained or not, whether the right constructs are being used or not. Just switch chahiye to wahan if use kiya hai kya, she will check that, whether the right kind of loop structures have been used. Static whiteboard testing. Static ka matlab hai, you are not going to run the program. You will statically only open up the source code, the file, and you will review the file. Code review you will do. You will review that file. Then we have dynamic white box testing. Involves testing and run the program to test the internal logic of the program. तो आप code देखोगे भी और उसे execute भी करोगे, but in black box we did not see the code. You will see the code, run the code, and then see the internal logic whether it is taking care of all the requirements or not. So there is black box testing and there is white box. In black box testing, we are only concerned with the output. For the given input, do you get the expected output? In white box testing, there are two types, static and dynamic. Static white box testing, what we do is, we take the code, we run it, correct? No, we take the code, we open that file, source code, we review that code manually. We just have a look at that source code. We do not run the code. In dynamic, as the word says, dynamic, static is like fixed. We just see the code and we suggest some changes that can be made to the code. And in dynamic whiteboard testing, what we do is we run the code to see the logic is correct or not. It's not like static where you do not see the code. You see the code, you run the code, and then suggest some changes that can be made in the code, the logic. In black box testing, you don't make any suggestion. We are only concerned with the output aa raha hai ki nahi aa raha hai. Right? In white box, we want to improve on the logic, whether light constructs have been used or not. So these are some very broad terms, but they are the terms that you may come across very often. That's the reason I have just identified those terms for you. Here, what those terms are. that you have done the testing, क्या करना होगा? Said something earlier. What would the next step be?
Documentation.
Documentation. No.
Error corrections.
Correction कर लिया. You identified means you also taken care of. So testing के बाद you identify, you will also do the corrections. Next.
Deployment.
Deployment. Have you designed that code for yourself? Are you going to keep in a shelf? हाँ, this was my efforts for 1 year. ये मेरे 6 महीने का काम है, ये मेरे 2 महीने का काम है. और घर में क्या तो बना के रखोगे? You are developing the code for the client. So if you are developing the code for the client, would you not like to go ahead and implement that code at the client place? Because while you implement the code at that client place, there will be other kind of testing also that we'll have to do. That's a different story altogether. But we have developed the code for the client. So we actually have to go ahead implementing the code at the client's end. Code to लिख दिया आपने. The system that you develop, application that you have to deploy that particular code, put that code to use. You have done the testing, but that's not actual use. It's the client who will be using that code actually. So you have to deploy that particular system at the client's end. And that's implement and maintain the program. System is installed at the client's end. We have to give a demonstration of the system and perform test runs in the actual scenario. आपने जो भी टेस्टिंग किया था वो तो सिर्फ बेंच पे टेस्टिंग था. The software, suppose the billing software है, we'll put it at the counter and we'll run that particular application at the counter to see जब customer आ रहे, is it printing correctly, is it giving you the right kind of calculations, is it maintaining the records correctly. So we'll actually, in the actual case, we'll do the testing. Actual place, we'll install the system and do the testing. Necessary changes are made to the system to fulfill the client's requirements so that the system remains useful. Now, this statement is also very important. Client had given you some requirement, okay, and that requirement was given 6 months back, based on which you have developed the system, and the government rule changes. Now, are you going to still tell the client, no, government rule has changed, but आपने दिया हुआ मेरा requirement पहले का था, I'll only do as per the previous requirement. I'll not incorporate the new government rules that are asking you to make the changes. Now, if you don't make the necessary changes in the code, where the external factors are forcing that particular business to make the changes in that particular way the calculations are done, that system is of no use. पहले GST नहीं था. You designed the system for the client and then government applied GST. So I gonna tell the client, no, I'll not now do, I cannot help you. Now place a new order for a new system with GST. But what to do with that existing system which was without GST that you are in the process of developing and you're currently implementing. So you'll have to make the changes in the system. Otherwise, the system is of no use to the client if it doesn't take care of the changing requirement of the client. And requirements always keep on changing. They always keep on evolving. So this particular activity of maintaining the system stops not after you have installed the system at the client's end. The activity of mark my word, the activity of maintenance of the software stops only when client discards the system. It throws away the system. That's the only day when the maintenance activity stops. Otherwise, as long as the system is in use, throughout its life, it has to be maintained. Because there is no such requirement which is fixed. Requirements are going to evolve, new requirements will arise. So maintenance is a lifelong activity. Maintenance is a lifelong activity. It starts the day when you deploy the system and stops only when the system is discarded. Jis din system use karna band karoge, only then the maintenance stops. It's a continuous activity which is there. System is updated and modified to cater to the changed requirements. And the world is dynamic. Requirement keeps on changing. So you have to update the system. You have to make the changes to the system. There could be virus attacks. There could be so many. There is a Trojan. You may not have thought about situations where the machine are outdated. Now new machines have come. You will always have to provide support for the system. And the support will stop only when the client says, I no longer plan to use this system. That was maintenance. And then there is documentation. But believe me, documentation is actually not the last step. Documentation starts the day when the client approaches you for the first time. जब client आपको पहली बार मिलता है, तभी से documentation start हो जाता है. And documentation also stops when the client stops using the system. Say you met the client. Client gave you a requirement. That's a document that he has given. Once that requirement is given, you define the problem. That's another document that has got created. You created a proposal for the client. That's another document that has been created. All those pseudo codes, flow charts, whatever you have done during the entire system, all those ER diagrams that you have done, all those are documents. And these documents are necessary for you to maintain the system. If I do not have the algorithm of a program, how will the maintenance guy go through the entire code to understand the logic? No, he'll rather go through the algorithm. Algorithm समझने के बाद, then he'll look at the code. So along with your code, you should also have algorithm. You should also have documentation. There are different types of documentation that we have. It is a process of collecting, organizing, storing, and maintaining a complete historical record of programs and other documents used or prepared during different phases of the life cycle of the software. Whatever documents are used, whatever documents are prepared historically, right from collecting information to organizing, storing, everything, that everything needs to be documented correctly. Because says tomorrow, I did not ask you this. So you should have shown him the document that you had gotten approval from him for this particular requirement. It is this requirement that you have given to me. So it's a process of collecting, organizing, storing, maintaining complete historical records of the program and other documents that are used or prepared. So for developing, you have used that document or you have prepared that document during the development process. So in all entire life cycle of the project, whatever are the documents that you have come across, everything needs to be organized correctly because you never know what you'll need later. 5 years down the line, you come back to the same project and only if the documentation is there, you'll understand which program does what operations. There can be hundreds of programs within an application. It will be a nightmare kind of scenario. If some printing is going wrong, how will you identify which program in this hundreds of programs is doing the activity of printing without documentation? So you need to have documentation. There are two types of documentation, major categories. एक है process documentation और एक है product documentation. Process documentation is for the developers. It's a programmer manual in which all the functions, their description, their documentations are given. And product manual is for the users because user is going to use the system. You're going to maintain and develop the system. So the information that you need and the information the user needs is very different. User को मालूम होना चाहिए मेनू में क्या क्या ऑप्शन है, हर मेनू का ऑप्शन क्या करता है. डेवलपर को मालूम होना चाहिए वो मेनू के लिए लॉजिक कौन सा है, कौन से फंक्शन हैज दिस पर्टिकुलर मेनू एंड सो ऑन. It takes care of the menu. So we need both the kind of documentation, the process document as well as the product document. Two most important documents, but these are not the only one. Process documents are meant for the programmers, the maintenance guys, the development team. It is meant for the client. Okay, for him to make use of your system optimally. Okay, but then there are other documents like contract. So Bhagyashree develops an application for Rohit. Bhagyashree and a team of 10 people are working for last 6 months day and night to develop that system. They develop the system is very nicely working. Now they go to their client Rohit and they give that CD to Rohit, a pen drive to Rohit saying, sir, ye humne system create kiya, it is fulfilling all your requirement. Rohit takes the pen drive and Rohit says, okay, how much does this pen drive cost? Bhagyashree said 2,000 rupees. He said, chalo, aapko main 5,000 rupees deta hu. Take this 5,000 rupees, 2,000 pe ka pen drive, main aapko 5,000 rupees deta hu, go away. And Bhagyashree and team have worked for 6 months on that project. 10 people working on 6 months. And he says, no, sir, iska cost 10 lakh rupees hai. Rohit said, I'll give you 5,000 rupees. When Bhagyashree is claiming 10 lakh rupees, Rohit says, okay, nahi chahiye mujhe, aapka pen drive leke wapas chale jao. But these guys have already invested their time, effort, and money developing that system. So if you have a legal contract with you, then you can get hold of Rohit, sue him, take him to the court, and not just charge him for the task, also charge him for the interest over the delay that has happened. You could do that. It could be other way around also. Has faith in Bhagyashree. Rohit gives Bhagyashree and her team an advance of 1 lakh, then another advance of 5 lakhs, where the total bill was only 10 lakh rupees. And Bhagyashree had promised that system will be delivered in 6 months. And Bhagyashree now delays it by another 7 months, 8 months, 10 months. Is Rohit going to wait for that particular system endlessly for that system to be developed? So that contract, which is legally binding, will help the client as well as the developer. If anybody violates that particular contract, he can be legally sued. So there are other documents also which will be there, which are a part of that documentation process. So you have process documentation, you have product document, you also have contracts which are being signed to safeguard the interest of the client, to safeguard the interest of the developer, because anybody may falter. The client may not keep his word, the developer may not fulfill his commitment. So everything needs to be properly documented. So there are a number of documents you're going to come across, major being the process and the product document, and there are other documents also which are actually there around, which you should be really worrying about. Is that okay? Sairam is sharing something. Sairam, can you share that? What happened? What was the charge for delay in this thing?
There was some training simulator,
Ah.
and means as
Sairam
promised.
is working with Veritas, huh? And so he's talking about.
No, not in current project. In previous company only.
Yes.
What I said yesterday, it was a training simulator. Means what the exact thing you have to drive. Then first you have to train, not
Correct.
on actual object, but in simulation environment, like we drive that.
Maruti Driving School.
Yes, like that. So that training simulator should be delivered within some 1.5 year, and
Okay.
some delay was happening. So then they have sent one letter stating that 1 CR will be charged per week delay.
Look at that. Delay charges kitna hai? 1 CR per week. It was a stimulator for the submarines.
Yes.
So there are huge implications which are there. Okay. And think about the project cost then. How much the company must have been paid. If the delay charge of 1 crore, the company bill may be several hundred crores.
Yes.
Correct? So
Yes.
everybody's interest should be safeguarded because they have their entire system waiting for that particular training stimulation to be created. People are to be trained. And if that particular system is not delivered in time, all the plans will fail. Okay. So that was very important that we have that legally binding document which can be enforced on either party. Dono party ke aap usse force kar sake. So both parties can be made to adhere to that particular thing. So that was about again, documentation stops only when the system is discarded. Stop when you stop using the system. Otherwise, the documentation is a lifelong process because say Prithviraj team is the maintenance guy. The Prithviraj team comes and makes some changes to the code and they do not document it. Now tomorrow Prithviraj leaves the company and Rahul joins that company. Will Rahul understand? Because algorithm is saying something and Prithviraj already made the changes which are not reflected in the algorithm, in the source code. So every change that you make in the system also needs to be properly documented. Otherwise, it's going to create a situation where you just cannot maintain the system. When idea comes to your mind, I can tell with confidence, if Sairam also comes with an idea, and if he tries to touch a code which is already there, does your company allow you to make the changes in the code which is already there? Sairam?
No.
Because that could have a snowball effect at somewhere else that you do not know where that particular problem, so thing will fail. So making changes in the legacy system is the like a decision that most of the senior people will also not have the courage to do that.
Yes.
They will not let you do that. They will say, hold on, new system you do whatever you want, but exist system, they will think 100 times before. Sometimes the changes are to be done when there is a bug, but the most scariest part is to make changes in the existing system. Isn't that the case, Sairam?
Yes, sir.
You never know which function has been used where, by whom, how many times. And you make changes assuming that this is the only place that function has been used, and the use case may be something different in some other case. And that entire system may crash. Very, very difficult. So everything needs to be documented. Your changes made at one place can affect the system at some other place as well. So you have to be very careful about Sairam reminds me of a company that I had worked on. Let me cite that example. Okay, he reminded me my example only. Several years back, I took a training for a company called as Principal Software, and that for working on Java. We trained that employees. I asked the people like, why you want to learn Java? They said, we want to move from COBOL to Java. So look at this. They wanted to move from COBOL to Java. They were working for one of the biggest American insurance company. They were working for one of the biggest American, rather it was in-house project for them. Principal, that company itself is a insurance company in America, and they have their software development team in Pune. And they wanted to switch to a newer technology because Java, Oracle, COBOL is like file systems, and that's of 1960s ka idea hai, 70s ka idea, 60s and 70s ka idea hai. So they wanted to migrate to a new platform, Java and other new things that they wanted to use. I trained them. They all got trained. They all were very good in Java. They were working on Java. They built the system in Java. And I met them after some years, asked them, how is it going? And even after several years, they had not moved 100% from that COBOL to Java. Because it was an insurance system. Think about a scenario where some calculation somewhere has gone wrong. Okay, kahi to uska interest rate ka calculation mein agar kahi bug hai, so how much impact will it have on the total the calculations for the company if some calculation goes wrong somewhere? आपके Java के program में एक छोटा सा bug है, and that COBOL program is running, although slow, it is running correctly. It is being running correctly last 40 years. And insurance is like they have insurance for 100 years, 20 years. What kind of insurances you have? Now, if some calculations goes wrong somewhere, who is going to own that responsibility? So for several years, for more than 5 years, they were still making transition from the working COBOL system to working Java system. They were using both the systems parallelly. Did not have courage to switch over to another system because they were not, because this last system was working correctly for last 40 years. Now to go to a new system, nobody was ready to take that particular decision and responsibility and a call, final call, कि चलो अभी इसे पे switch हो जाते हैं. Nobody could take that decision. Why? That fear. अगर इसमें कुछ bug है तो what would happen? The company will close down, entire company. अगर कुछ calculation में गलती हो गई तो. And insurance values, you don't know, when you talk about international trade and other things, insurers are in billions of dollars and so on. That company, it was fine. I need to check with them again. Abhi to completely switch kiya hai kya nahi. Okay. But I knew at least for 5 years they had not made a switch from COBOL to Java. Although the team of Java developers were ready, Java code was ready, but it still did not make a transition from COBOL to Java. It's a very difficult decision to make. Very difficult decision to make. Because risk involved is very, very high. Risk of failure. So that's actually all that we had to discuss. It's time for us to actually go with some kind of exercises. Now, even before I go to the exercises, just let us pay tribute to some people who have contributed tremendously to this concept of algorithm. The word algorithm itself has been derived from the 9th century mathematician called as Muhammad bin Musa al-Khwarizmi. Okay. The word algebra comes from Arabic algebra, whatever it is. And this fellow, whose name is Muhammad bin Musa al-Khwarizmi, he is the one who was credited with this concept of coining this particular term called as algorithm. What exactly algorithm is? So an Arab, mathematician, okay, who came with this particular concept of algorithm. Arab भी नहीं है, थोड़ा सा पहले ईरान से, Persian. Okay, Persian mathematician and astronomer called as Al-Khwarizmi, whatever it is. Persia means today's Iran, today's Iran. So he was an Iranian, and there are a lot of in the past. There was a time when the Muslim world today is like most backward in terms of technology, innovation. But there was a time in the late 9th and 10th century and 8th century, that was a time where researchers, a lot of scientific kind of research that were done in the Middle Eastern, the Arabic, the Muslim world as well. But then over a period, it faded out. Okay, today we hardly find that part of the world, say Iran, Iraq, Saudi Arabia, or the Gulf countries and other. We will hardly find that kind of research happening and so on. Okay, business happening, money is there, that's a different story. But contribution to the maths and physics and other things, but that was not the case in the last, before 9th century, 8th century. There was that time, that was actually before 10th century, it was a golden period for them. A lot of research happened. So just to know about them, okay, Al-Khwarizmi, he's the one who came with this term called as algorithm. Second fellow that we should know is like Ada Lovelace. She was the first computer programmer. So the first computer programmer was a lady and not a man, a gentleman, lady. So we are going to learn programming. So we should also know about Ada Lovelace. We do celebrate every year one particular day in the year. Find out which is the day that we celebrate by her name, Ada. What she did was to write the world's first machine algorithm for an early computing machine that existed only on paper. Charles Babbage, even before that, there was a French scientist who came with an idea as to how a computer can be designed. Listen, he came with an idea as to how a computer can be designed. The machine was not real. The machine was only an idea. She wrote a program that could run if that machine was really created. Think about it. So a fellow comes with an idea as to how we can create a computer. She writes a program for that computer which is yet not created. And believe me, when the machine was actually built based on that idea, the program that she had written did work correctly on that particular machine. So she could write a program when there was no computers. So for you, you should not bother about computers. You can also write a program even before you touch your machine. The reason why I took example of Ada Lovelace, the first computer program was written even before the computers were created. So if somebody tells me today, sir, wo programming nahi aa raha because I don't have a good machine, you are fooling yourself. For programming, for algorithms, for thinking, for designing an idea, you don't need computers. You can start thinking, you can start programming. Coding is only one chapter in the story of programming. So other chapters you can definitely complete even before you actually start writing codes. So keep in mind, first computer program was created even before invention of computers. So even when the computers are not designed, the computer programs were created. So we should be knowing about that. Ada Lovelace and Al-Khwarizmi, who created this term called as algorithm. So that was an introduction to this particular concept of problem solving. It's time for us to actually go into exercises. So I was planning 2 days, but it took us almost 3 days to complete this. But that discussion I felt was necessary for you so that you understand the significance about what we're going to do next. So next, the entire exercise will be about defining a problem, analyzing the problem, understanding the problem specifications, and then solving that particular problem. And I'll take up several examples. And once you go through that example, you understand the significance about why are we doing so. ये सब कुछ हम लोग क्यों कर रहे हैं, you'll understand. So from tomorrow, be ready with your pen and pencil. We are going to start with exercises. Next 15-16 days is only sessions is only exercises, nothing else. So every day we are going to solve some problems. I'll share some tools with you. I'll be sharing the link on your WhatsApp group. I want you to download those tools and keep it ready. Or shall I show you the tools right away? You'll download it.
Sir, how many are there?
Draw tools. So one tool that you're going to download. Is the browser visible?
Yes, sir.
One tool that you're going to download is you'll visit site called as diagram.net. Note कीजिएगा, दिखाई दे रहा आपको diagram.net, and you'll download this particular diagram.net first. Is that okay? इसको देखो diagram.net पे जाइएगा and just download that thing. You could do it without installing by starting in the browser itself. But I do not want you to work in the browser. I want a copy of it installed on a machine so that if I have to draw an algorithm, sorry, not this. If I have to draw an algorithm, if I go to draw.io, I should have all the tools which are required for me to draw an algorithm. So I say create a new diagram and whatever algorithm that I would like to draw, we have a flowchart here. If I say create, I'll have all the tools which are required for me to draw a flowchart. Yeah, and then I have to say, okay, there is a line connecting to it. So I should immediately, or if I have this, if I have to show the line, if I have this, and if I have to show a line, and that line is going to connect to this, I should be quickly in a position to draw. And this is free now. Earlier it was paid. So diagram.net से ये आपको download करके install करना है अपने machine पे. I do not want you to work in browser. I want this to be there with you. It's useful. And for Sairam and other people who are not allowed to install in a system, you can do it on browser. You can create an account and you can save in the browser. Second thing that I want you to have is something, दो चीज है, एक diagram.net नोट करके रखेगा. Link over here. So I've shared the link in the meeting. First thing. And let me also share the second one. Just give me a second. Is the browser visible, everybody?
No, sir.
One था diagram.net. Second thing that you will actually be searching for is something called as logarithm. Algorithm नहीं, logarithm. एक diagram.net और दूसरा logarithm. I'm sharing the link for logarithm also. ये भी link मैं आपके साथ share कर रहा हूँ. तो ये दो चीजें I want it to be there on your machine. इंस्टॉल करके रखना है. ये फ्लोगोरिथम, एक diagram.net और दूसरा है flogorithm.org पे जाना है. And here you'll have downloads. Download में जाके लेटेस्ट वर्जन को डाउनलोड कर लो. फॉर विंडोज यू कैन टेक एनी वन, 64 बिट 32 बिट जो भी आपकी मशीन है. विंडोज इंस्टॉल ले लो, ये इंस्टॉल करके रेडी रखो. सो वंस यू इंस्टॉल इट, देन विल एक्चुअली स्टार्ट विद द प्रोग्राम्स दैट वी नीड टू वर्क विद. तो फ्लोगोरिथम इज व्हाट आई वांट. ओके, दो चीजें आपको पता चाहिए. एंड आई विल टीच यू हाउ टू यूज इट, सो डोंट वरी अबाउट इट. तो
Sir, वो
diagram.net
not secure है.
pardon?
Not secure था वो website.
Good enough. Don't have to bother about it. It has been recommended by a lot of universities, so don't have to worry. And if you worry, then don't do it. Do it on a piece of paper. But then I have used it and I found it quite secure, so don't have to worry. So these are two things that I want you to download and keep it ready. So in the next session when we meet, we'll actually start off with some problem statements and I'll teach you various programming constructs and how to tackle them. So before we wind up for today, let's have a quick feedback about what we did today. Let's start with Viraj. Learning for you today.
Sir, बहुत कुछ है आज के लिए.
Highlight क्या है आपके लिए?
For sir, I would say testing methods were one, and selection of programming languages where you have to be ready with everything, and other was the testing, black box and white box.
Sairam. Sairam, you
So
cannot hear.
testing of algorithms,
Testing of algorithm, not the code, the algorithms. Okay?
how psychology works in
How
that.
psychology. Yeah, there's a lot of psychology is actually involved over there. It is the case. It is the case. Aditya.
Yes.
आदित्य सो गए क्या? आशीष.
Sir, first, the method of testing the algorithm, try error. Second, the different terminologies
Like
of black box testing and white box testing.
black box testing, white box testing. Okay. Agishri.
So testing of algorithm and bottleneck.
Bottleneck. That was very important. Bottleneck kind of concept. And who can help you with the bottlenecks? Identifying the bottlenecks?
Seniors.
Seniors. Okay. Well, anything else?
Errors while testing the program.
Oh, errors while testing the program. This is the one that we should not fear at all.
So the tip
Syntax.
syntax.
But that does not mean you should commit them. Huh? It's like you need not fear, but that doesn't mean that you're careless and you keep on committing those mistakes. That shouldn't be the case, but you don't have it. Which is the most dangerous error?
Logical.
Logical error, the most dangerous errors that you come across. Okay, next Prithviraj.
Types of testing, black box testing and white box testing. Black box testing tests the functionality, while in white box you like uh, the code is reviewed.
एक में review
Yes.
करते without running, एक में review करते with running.
Yes,
Static and
And-
dynamic is what we are seeing.
and types of errors, bottlenecks.
Bottlenecks, errors. Okay. Rahul.
So the techniques for algorithm like independent inspection and structured walkthrough are new for me. And the selection of best algorithm, that is least number of steps, easy to understand.
Criterias. That was very important.
Yes.
These were criterias for selecting. It should not be biased. I like Bhagyashree, so I'll take her algorithm. No. I reject Viraj code. No. I should have justification. Why? And that will happen only when you have some criterias based on which you're going to compare those algorithms. Okay, that was very important. Aditya?
Hello, I'm audible. Yes, sir. So today's learning was for me is implementation of algorithm and black box testing, white box testing, and that's all.
What is implementation of algorithm?
Implement used.
Aditya, you're muted. We cannot hear you.
Hello, yes,
Yeah.
sir.
Yeah.
Sir, programming and coding.
Okay.
Yes. And translating algorithm into a computable program using syntax and semantics. Of the
That
program.
language. So that's all. Be ready for tomorrow's session. Okay, have those tools with you ready, and we'll be using those tools in the classroom, and we'll work around, play around with that particular algorithm. So we'll take a lot of assignments. So don't miss any sessions henceforth, because all the basic construct that you learn in any language, C, C++, Java, Python, we'll go through all those concepts. All the major concepts will be covered here itself. So even before we start learning programming language, we'll learn all the concepts. So don't miss the session. Under any case, there are some good programming practices that I'll be trying to tell you. Some things that you should follow for your life, whichever company you work and wherever you work. So those things I'll be emphasizing upon. Make sure that you follow those things. Use it as I say. You will get to see the results in future. So thank you for in the session today. See you tomorrow. Take care. Love you all. Bye-bye. And Rohit, belated happy
Rohit's
birthday.
birthday.
Belated ना कल था ना?
कल Thank you, sir.
Belated है ना? Belated happy birthday. Yesterday we were waiting for you. You did not turn up.
Yeah, the guys took me out.
Saira was telling us कि अरे birthday की party मांगे इसलिए भाग गए.
Party देने गए थे.
Lonavala is a nice place. You could always call us at Lonavala. We can all come down at Lonavala.
Yes, sir.
for the
Yes, sir.
party. Yeah?
Yes, sir. Very.
Okay. So how was the day yesterday?
Yes, sir. It was good.
It was good. But why did you skip the lecture?
Actually, the time of lecture was at 8 p.m. I told that guys that it shouldn't be late, so they take me out at 6 p.m. But eventually they dropped me back to hostel at 10 p.m.
So we just go through the last session as well. Okay.
Yes, sir.
Happy once again. Happy birthday once again. Take care. Love you all. Bye bye.